Hello everyone, welcome to Brain Blitz Audios. In today's episode of NEET Preparation, we'll be looking at previous year questions of chemistry and medical entrance examinations in India. Today we'll be dealing with the chapter, the P block elements. Here we'll be looking at group 16, group 17, group 18, group 15 elements, and this is the 12th chapter. This is the 7th chapter in the grade 12 syllabus for chemistry in CBSE. Let's begin with our first question. The number of POP bridges in the structure of phosphorus pentoxide and phosphorus trioxide are respectively 6,6, 6,5, 5,5, 5,6. So these are the four options. So POP means that there will be two phosphorus and an oxygen in between them. So that kind of bond, we need to find out how many number of such bridges are present in phosphorus pentoxide and phosphorus trioxide. Well, let's count, shall we? Well, here is P4010, which is phosphorus pentoxide. So we have this as 1, this as 2, this bridge becomes number 3, this bridge becomes number 4, and this bridge becomes number 5, and this bridge becomes number 6. So there are 6 bridges in P4010. That means options B and C are becoming incorrect. Now, what about the bridges present on phosphorus trioxide? So this is 1, this is 2, this is 3, this is 4, this is 5, and this is 6. Even though the formula is different, they still have the same amount of POP bridges. So that means option A is the right option. And we did that by looking at the structure of P4010 and P406 and counting the POP bridges. So both of these oxides of phosphorus will have the same amount of POP bridges. Next question. The incorrect statement among the following is, and we need to find out which of these is incorrect. Option A states that C60 is an allotropic form of carbon. The statement is true. The name for C60 is Buckminster fullerene. It was one of the first fullerenes to be discovered, and Buckminster fullerene is also called as a buckyball. It's a special type of carbon allotrope. So option A is true, which makes it incorrect. Now, option B, O3 is an allotropic form of oxygen. Well, the actual form of ozone is oxygen dioxide, which again can be written as O3. So it definitely acts as an allotrope. So option B is also true, which makes it incorrect. We need to find the incorrect statement. What about option D? Red phosphorus is more stable in air than white phosphorus. Well, yes, this is true. So therefore, option D is also becoming incorrect because the statement is true. When you expose white phosphorus to air, it reacts vigorously, but red phosphorus stays as it is. So option D is also true, which makes it incorrect. The right answer is option C. S8 is the only allotropic form of carbon. This is false. There are over 30 plus allotropes of carbon. Some of them include rhombic, alpha, beta, monoclinic, etc. So there are a lot of types of sulfur allotropes. Therefore, S8 being the only allotropic form of sulfur is incorrect. The statement becomes false, and the false statement was the right answer for this question. Next question. The tincture of iodine is aqueous solution of iodine, solution of I2 in aqueous Ki, that is potassium iodide, alcoholic solution of iodine, aqueous solution of potassium iodide. Now over here, note that both aqueous solutions don't have any special name. So therefore, options A and D are incorrect. Now, what about option B? Yes, option B. Solution of I2 in aqueous Ki. This is known as Lugol's iodine and not tincture of iodine. So option B is incorrect. The right answer is option C, alcoholic solution of I2. Tincture of iodine is described as a 2% solution of iodine in alcohol. Therefore, option C is the right option. Let's move on to this question. Which two of the following salts are used for preparing iodized salt? KiO3, Ki, I2, Hi. The process for making iodized salt is as follows. NaCl plus KiO3 plus Ki gives you iodized salt. So therefore, KiO3 and Ki, which are options 1 and 2, are the salts used to prepare iodized salt. Therefore, option A will be the right option. In option B, it says that I2 is used for creating iodized salt, which is incorrect. In option C, it's saying that hydrogen iodide is used for creating iodized salt, which is incorrect. And in option D, both the salts given are incorrect. The right answer is option A, 1 and 2. And we found that out by the reaction. So 1 and 2. When we wrote the reaction down, we noticed that KiO3 and Ki are present in the reactant side. So these two salts are used for preparing iodized salt along with NaCl. This is the next question. XeF6 on hydrolysis produces XeOF4, XeO2F2, XeO3, XeO2. Now here hydrolysis means complete hydrolysis. Therefore, options A and B become incorrect because both of these are partial hydrolysis. Let's write the reactions down. So when we have XeF6, which is hydrolyzed partially with just one water molecule, you get 2HF and XeOF4. XeF6 plus 2H2O would give rise to 4HF plus XeO2F2. So these two are partial hydrolysis, so therefore options A and B become incorrect because here we're asking about the reaction when complete hydrolysis occurs. And option D, XeO2 is not a product of hydrolysis, therefore option C becomes the right option. And how is it part of complete hydrolysis? Here's the reaction. XeF6 plus 3H2O, which means all the fluorines react with hydrogen, so they form 6HF plus 3O plus Xe, so XeO3. That's why option C again becomes the right option. Next question. Inert gases are mixed in iodine vapors. Then the bonds that are present between them are A, hydrogen bonding, B, van der Waals forces, C, electrostatic forces, D, metallic bonds. So the important thing to note here is that these are noble gases of group 18 and they are inert. And that has a long way to go in identifying what forces are present between them. When it comes to option A, hydrogen bonding, this cannot occur because again, the inert gases are inert. They do not bond with hydrogen. So therefore, option A is incorrect. Similarly, option D becomes incorrect because among inert gases, there are no metals in group 18 so far. This ignores the 118th element, but all the other elements are included and they are not reactive. They are not metallic. So there will be no presence of metallic bonds. So option D is incorrect. Option C, electrostatic forces. Now for these forces to occur, there has to be a charge difference, which is not found in the case of noble gases because they have a stable electronic configuration, so they don't have to change. So therefore, option C becomes incorrect. The right answer is option B, van der Waals forces. The specific kind of van der Waals forces that affect noble gases are known as London forces. So these van der Waals forces can occur between any two substances, whether charged or uncharged. So if inert gases are mixed in any kind of vapors, they are held together only by van der Waals forces. So option B becomes the right option. Next question. The element which is the most abundant in the Earth's crust is oxygen, sulfur, aluminium, hydrogen. Let's write down the percentages of each option. Hydrogen is present in 0.14% of the Earth's crust. Not a big number, is it? Well, look at sulfur. Sulfur is actually even less, so 0.042% of the Earth's crust is made of sulfur. None of these compare to aluminum, which is about 8.33% of the Earth's crust, but all three of these are dwarfed by the amount of oxygen, which is 47%. About 47% of the Earth's crust is made of oxygen, which is why oxygen becomes the most abundant element in the Earth's crust. And the reason why is because most of the compounds which are present in the Earth's crust are oxides, or even when they're carbonates or sulfides, they still have oxygen in them. So oxygen is a part of most compounds, and most of the compounds that are present in the Earth's crust are oxides. So therefore, option A, oxygen, becomes the most abundant element on the Earth's crust. Let's look at this question. Cyanogen gas is obtained in the reaction. Now, formula for cyanogen is Cn twice. So this is the formula for cyanogen, and we need to find out in which reaction does this occur. Well, CH3CONH2, which is urea, plus P2O5, on heating gives you CH3CN plus P2O6H2. So option D is incorrect. What about option C, CH3CN plus H2O? And when they're heated, this actually forms acetic acid, CH3COOH plus NH3, which is ammonia. So option C becomes incorrect. What about option B, K4FeCN6? Again, this option becomes incorrect because this does not form cyanogen gas. The right option is option A, CuSO4 plus KCN. Let's prove it. So 2CuSO4 plus KCN gives you 2CuCN twice plus 2K2SO4, and then the CuCN2 decomposes to form 2CuCN plus Cn twice. And the Cn twice is cyanogen gas. So option A becomes the right option. It's from the decomposition of the unstable cupric 3 cyanide, copper 3 cyanide, that we get cyanogen gas. So option A becomes the right option. The question states, per disulfuric acid has the following bond. Does it have a coordinate bond and a double bond? Whether it has two coordinate bonds for oxygen, which have a double bond in between, whether it has a coordinate bond in between the two oxygen atoms, or just it has a normal single bond. So let's look at a structure of per disulfuric acid. As you can see, this is H2S2O6, H2S2O8. H2S2O8 is per disulfuric acid. Now, as you can see, the bond here will only be referring to the bond between the two oxygens that straddle the boundary between the sulfurs. So essentially this part. And as you can see, it's only a single bond between the two oxygens, and there is a single bond that bonds the oxygens with the sulfur, their respective sulfurs. So therefore, option D is the right option. As you can see, there are no coordinate bonds here, so A and C are incorrect. And since there's no coordinate bond between sulfur and oxygen, option B becomes incorrect. The right answer is option D, single bonds between the two oxygen atoms. This is the final question of this episode. S2 minus and SO32 minus can be distinguished by using. So we have a sulfide ion and we have a SO32 minus ion, and we need to distinguish between these two. So the options given are CH3COO twice Pb, lead acetate, Na2FeCN5NO. So option A is lead acetate, option B is Na2FeCN5NO, or option C, whether both are present, or option D, none of these. So when it comes to S2 minus and SO32 minus, they react differently. So S2 minus reacts with lead acetate and then it forms PBS, and PBS is black. While S2 minus reacts with FeCN5NO2 minus to form FeCN5NOS4 minus. So this S2 minus reacts with both lead acetate and Na2FeCN5NO. So therefore, we can use both options A and B in order to distinguish between S2 minus and SO32 minus. So option C will become the right option. Since both can be used, therefore option D, none of these will be incorrect. And if we were to choose either A or B, then we will be disproving the existence of the other. So therefore, both options A and B become incorrect, and their union, option C, becomes the correct answer. So that concludes this episode of NEET preparation. There are a lot of questions in NEET exams which correspond to P block elements, so you can refer to our earlier videos by clicking the link in the description down below. For more of our useful and interesting content, please don't forget to subscribe to our channel, which is Brain Blitz Audios. So until the next episode, take care, stay safe, bye-bye for now.